So here's what I've got. I've got, my screen is too dark. There we go. So here are our test scores down in L1. All right. Sure I did it right. Looks like I did. And then we've got, okay, L2. I'm going to write this on the board to keep track of this. So the scores are in L1. Okay. L2, L3, L4, L5. Core Plus are L2 and L4, right? Okay. Core Plus, Core Plus. L2 is without calculators.
Yep.
4 is with.
Yep.
Okay. L3, therefore, is traditional without calculators. And L5 is traditional with. Whew. That's a lot of data. It's good. We're going to do some data mining. Do some data mining, which is, there's our data. What does it tell us, if anything? That's the beauty of it. Chris, go ahead. We got.
My L3 says L4.
Well, then press stat 5 enter, and it will be back. I know you did. You just tested me. Hopefully I passed your muster. So the idea here is we've got a bunch of data, but we have no idea if it actually shows us anything. So now we're going to go in there, take a look at the data, and see if it shows us anything. Carrie, everything cool?
Yeah.
Okay, awesome, awesome. So what do you say? Do you guys have any research questions that this data might be prompting in your minds? Based on test scores. We're going to make an assumption here. Let's make the assumption. A higher test score indicates better understanding of mathematics. Let's trust the assessment model, okay? Let's trust the instrument. So what do you think? You have any hypotheses you want to test based on the data? Does anything jump out at you? It might not. Darla, say that again, please. Say that again. No, please, because what you said was awesome. I think I heard you say we should look at it? Well, I think we should, Darla. I think blindly applying a hypothesis to data we haven't looked at is kind of silly. Thank you, sister. Yes, let's look at the data. Which data do you want to look at, my friend? Any in particular?
All of it.
All of it at once? That's totally cool. One problem. We can't, because the TIs suck. We can't graph 4 data sets at once. We got a max of 3. So may I recommend we pair them off 2 at a time? Because 3 doesn't make a whole lot of sense. Why don't we pair them off without calculators first, and then with calculators second? Is that cool? But Darla, I'm with you, sister. Yes, we should look at it. Because the graphs might give us an indication of, oh, the graph says we should maybe test this as higher than this. Because perfect. I love it. That's great. That's the best idea yet. Let's turn on 2 box plots. I would say 2 histograms. I would. Actually, I just did. But in the TI, graphing 2 histograms is usually a bad idea because it puts them on top of each other and you can't see them. In Excel, it's freaking awesome. It's great in Excel because you can actually put them side by side, make them different colors. TI blows. But box plots are good because they put them on top of each other, above each other, excuse me. So let's go to stat plots. Let's turn plot 1 on. Set it up as modified. Sure, we should probably look at a modified box plot. I'm guessing only because if there are outliers, it might yard or average around. We might want to consider that. As far as X list and frequency, what do you think are going to go in there, friends? L1 for X list for sure. Absolutely, because that's where your data is, right? Your data, the test scores are your data, and they're all in L1. So all your X lists are going to be L1 for all these graphs. What's going to go in frequency? Why not L2 for starters? And all we got to make sure, oops, hit the wrong button. All we got to make sure is we remember that this plot 1, is graphing the Core Plus kids without calculators. Does that make sense? That's why I wrote it on the board. So when we go back and look at the graphs, we can tell which one's which. Fair enough? Yeah. Beautiful. That was ready to go. Let's turn on plot 2. Turn him on. Turn off the histogram. Go with a modified box plot as well. How about X list and frequency here, friends?
L1 and L1.
That is perfect. L1 and L3. Remember, L1 is always going to be your data because that's where your test scores are. L3 is pulling the frequencies of how many kids got those test scores. That's what we need. We need those frequencies. Hopefully this is becoming... I'm hoping that as we start saying like this, you're starting to say, God, Rule, you say this all the time. I'm hoping that starts to ring in the back of your mind. Because I know in 243 we don't hear it enough. Even though I say it pretty much daily there too. But it takes that long time for it to process itself. When you look at a histogram or grouped data, you have to take a weighted average. And that's what this is a weighted box plot for the data. Ready to rock?
Yep.
I say we turn these things on. Zoom 9. Okay, there they are. Now remember, I've forgotten, I don't know which one's on top right now. So I'm going to press trace. I'm going to press trace. Okay, plot 1 is the Core Plus kids. That's the core. Ashley, go ahead.
Error due mismatch.
Turn off, go back. Let me see real quick. It's got to do with your lists. Let me just look at your. L3, L1, L2, that's fine. There you go. You're golden now. You got an extra 0 at the bottom. Okay, friends. So, there are the Core Plus kids up top. Make sure we can see this. You can't. There we go. Here are the Core Plus averages, or I should say test scores, not averages. Here's the median score. Here are the traditional kids' scores. Okay? What do you think? What do you think? We can't measure statistical significance with box plots, but go with a gut. We have a test that will do statistical significance. Go with your gut right now. Is anybody appearing to do better? It looks like the traditional kids might be doing better. Let's compare quartiles, right? As far as the max goes, the max is about the same. As far as the 75th percentile, a smidge higher on traditional. This is kind of telling.
Yeah.
That's kind of telling. Look at that. The median is Q1 for the traditional. The median of the Core Plus kids is Q1. That means half of the kids are doing worse than this score. Only 25% of these kids are doing worse than that score. You see what I'm getting at there? So that might be telling. That might be telling. I think that might actually give us something to test. Maybe, actually, you guys take me. Maybe we should test this hypothesis. What do you think? What do you think we should test? I think we should test this. But test what? It looks different.
Oh, a little bit. Your line looks like it's farther to the left than.
Oh, it does look like. Well, you have a frequency. You have to have L1, L2. Make sure you have your frequencies in L2 and your graph mat.
I thought that I said there's a significant statistical difference between test scores of traditional and the Core Plus.
I think we should test it. I think we've observed it. This is why Darla, I'm interested to big about what you said. Yes, this gives us an idea of what to test. Otherwise, we're going to blindly run 6 tests. There are 4 data sets, correct? We can blindly run 6 tests and pair them all off 2 at a time, or we can look at the data and say, oh, maybe we should test this. I don't think anybody would say, these kids look like they're doing better than these kids, although that's a test we could run, but you wouldn't do that as soon as you saw this. So I think we should. Let's define some variables over here, okay? Let's define mu1 as the scores of the Core Plus math curriculum kids. Let's do this every time. And then mu2 as the scores of the traditional kids. Let's let those 2 always be our variable, just to keep it consistent, because I think we're going to run at least 2 tests. Might even want to run 3 after we're done. Might even want to run a 3rd. Maybe. We'll see how time lets us go. Cool? So I think we should run the first test is on these data sets right here. What if we don't let them use calculators? So let's make that a subset 1 here. Subset 1 without calculators. All right? What are our hypotheses going to look like? What are our hypotheses going to look like? Susie, go ahead.
So the first one is the traditional kids score higher without calculators.
I agree. I think that's what the box plots are implying. That the traditional kids, mu2, are actually averaging higher than the non-traditional Core Plus kids, which is in mu1, without calculators. Make sense? Although I love putting the null in there too. I forget somebody, Lindsay, you asked me last time. You're like, wait a minute, can we put the null into? Absolutely, friend. Absolutely. Put it in there. Absolutely have the null hypothesis in there. That never hurts to have it there. But the kicker is to make sure you have your research. You have your research hypotheses, so you know what sign to use. You can also write it mu1 less than mu2. That's the same thing, correct? That's the same thing. mu1 less than mu2. Whatever. They mean the exact same thing. That's why it's important to know what your variables stand for. What's the matter, Carrie?
Oh, nothing.
You sure?
Yeah.
Okay. All right. I won't upset anybody. Let's test it. We're done. That's all we got to do. We've got our data in. We got our hypotheses. Let's test it. All right. So, fire it up. The box plots have been great, but we don't use those to do the test. That's descriptive. We need inference. That's where the t-test comes in. We have to normalize for the standard error and so forth and so on. Tests, go find 2SAMP-T. He's right there in number 4, which is extraordinarily convenient. 2SAMP-T. We have data this time. We definitely have data, which makes the screen significantly smaller because you don't have to give summary statistics. All you've got to do is make sure you fill in the screen properly. So, what do you think goes into list 1? L1, definitely. List, I can't stand this. I can't stand the TI does this. It calls it X list sometimes, and here it calls it list 1 and list 2. These are both the X lists. Why it changes the name here, I don't know. These are both where your data is. And I apologize. But that's just the way the language is. So, what's going to go in both of those, friends? They're both going to... I did it again. They're both going to be L1. Absolutely. They're both going to be L1. What's going to go in Freak 1? I think L2 is a pretty good thing to put in there, because that's our Core Plus kids. And then L3 is going to be our traditional kids. Is that fair? It's a little convoluted because of the way the TI names it, but basically, this is what you graphed in box plot 1, and this is what you graphed in box plot 2. I wish they had these two switched so they were paired together, but I wish TI would do a lot of things and they don't. So we just live with it. It's all good. Fair enough? All right, here we go. Now we got to pick the sign. Careful with this. It puts U1 on the left and U2 on the right. So you want to make sure you use this sign because that's got U1 on the left and U2 on the right. You see what we're getting at there, friends? You see, again, it has its U1 over here. So you got to make sure the sign here matches that. If you just had this, that's okay. But you have to envision this going this way, U1 less than U2. Fair? Yeah, I think so. Okay, so actually it's in the right place right there. What do we do with pulled?
No.
Always leave it on no. Absolutely no reason to change it, ever. Shall we draw? Shall we draw? Yes, let's see if the box plots get in the way. They don't. They're out of the view. All right, and there's some area. So we got some area. And that's where the area should be. That's where the area should be. Let me ask a related question before we finish this test. How could you know you put the signs in wrong based on what you saw right now? For example, if I put the signs in wrong, if I put the sign in wrong and then ran the test, how would you know that you put the sign in wrong based on the fact that you got all that area? How would you know? How would you know it's reversed? I guess that's my question, I guess.
Just looked at the box plot.
Because, Michael, say that again.
Because you just looked at the box plot.
Because you just looked at the box plots and you know the Core Plus kids are doing worse than the traditional kids. So you know you should be headed this way, and the negative says that. If you're testing that they're doing worse, you're not testing that they're doing better. You're testing that they're doing worse. That's why I think, Darla, what you said was so crucial. Look at the data. Now, on an exam, I'm going to tell you what to test. On an exam, I want to tell it to you. Lindsay, is that what you were going to say? I'm sorry. Was that what you were going to say about? Yeah, look at the box plot. Look at the image. You wouldn't be testing that they're doing better. You're testing they're doing worse. The question is, are they doing significantly worse? And the answer is, yes, it appears they are. Let's get the correct p-value, although we could just look at that one as the complement. But what the hell? Let's get the right sign up there. It appears they are doing significantly worse because you got a test statistic of negative, what is that, 2 point something?
2.2.
2.2, thank you, friends. With a p-value of about, was that 1.5%. Which means it's much more likely that the curve is to the left of that curve. What value is here, friends?
0.
Always 0. Always 0. What's interesting about that now, and I'm going to put that as a blackboard, is that is now representing the difference in the averages. It's no longer just one parameter like it was back here. It's now actually the difference between two parameters. It's still 0, because it has to be 0 if your null hypothesis is that they're the same. If they're the same and you subtract them, it's going to be 0, right? So that's why the numerical value is still 0, which is beautiful for us, because we want that. We want to compare it to 0 every time. So -2 standard deviations left is significant. That's like expecting a 6-foot tall person and getting a 3.5 foot tall person. That's exactly what it is. Oh, okay. This could be very unusual. Maybe this person comes from an average of 6 feet, and I just got the random outlier. Or this person comes from an average with less than 6 feet. That's what you're looking at in a kind of a stupid, arbitrary way. Fair? So, our conclusion is what? Let's start stating our own. What's our conclusion?
Traditional students are doing better.
Good. If we let them, or if we don't let them use that, right? I'm sorry, I phrased that question wrong.
It's okay.
It appears that traditional students are doing better, or conversely, the Core Plus kids are doing worse.
Yeah.
If you don't let them use technology. Cool? Cool. Let's take 5 and then test the with calculators results. So, what's that? No, okay. I keep hearing things, but I'm old and deaf.